Something weird is happening in the cold darkness of space, and astronomers around the world are scrambling to figure out what they're looking at. When telescopes first spotted this massive object hurtling through our solar system at impossible speeds, they thought it was just another space rock drifting between the stars. But then the James Webb Space Telescope turned its incredibly powerful infrared eyes toward this mysterious visitor, and what it found has left scientists completely stunned. The images coming back show things that shouldn't exist, according to everything we know about how objects behave in space. Is 3I Atlas following the laws of physics, or is something else entirely controlling its journey through our cosmic neighborhood? What could be powerful enough to push a mountain-sized object through the void? The discovery that changed everything. July 1st, 2025 started like any other day for astronomers around the world. Telescopes were scanning the night sky, tracking the usual parade of asteroids and comets that drift through our solar system. But by the end of that day, everything had changed. A discovery was made that would force scientists to question their most basic assumptions about what travels through space. The first alert came from the Catalina Sky Survey in Arizona, part of a network designed to spot potentially dangerous asteroids before they get too close to Earth. Their automated systems had detected something moving incredibly fast through the constellation Draco. This object was traveling at 130,000 miles per hour, fast enough to cross the entire United States in less than 2 minutes. More importantly, its trajectory showed it was coming from outside our solar system entirely. Within hours, observatories across 6 continents were turning their instruments toward this mysterious visitor. The European Southern Observatory in Chile, the Keck telescopes in Hawaii, and dozens of other facilities began tracking what would soon be designated as 3I Atlas. This made it only the third confirmed interstellar object ever detected, following the famous Oumuamua in 2017 and 2I Borisov in 2019. The first thing that caught everyone's attention was how this object moved through space. Most asteroids and comets follow predictable paths, governed entirely by the gravitational pull of the Sun and planets. You can calculate where they came from and where they are going with remarkable precision. But 3I Atlas was different. It was accelerating in ways that made no sense, getting a constant push from some unknown source. Traditional comets accelerate away from the sun when solar heating causes ice to vaporize and shoot out like steam from a kettle. This creates a natural rocket effect that pushes the comet in the opposite direction from the escaping gas. But 3I Atlas was accelerating toward the sun, which suggested something fundamentally different was happening. The object seemed to be under some form of active control, as if it had its own propulsion system quietly firing in the darkness of space. When NASA brought out the big guns, the strange behavior of 3I Atlas prompted an unprecedented response from the international astronomical community. Within weeks of its discovery, a decision was made that had never been attempted before for an interstellar visitor. The James Webb Space Telescope, humanity's most advanced and expensive scientific instrument, would be redirected from its planned observations to focus exclusively on this mysterious object. This was not a decision made lightly. Webb's observation time is more valuable than gold, with scientists around the world competing for just a few hours of telescope access. The telescope represents the culmination of decades of technological advancement and international cooperation. Positioned at a point in space 4 times farther from Earth than the Moon, it operates in the frigid environment of deep space, where its instruments can detect the faintest traces of heat from objects billions of miles away. Unlike optical telescopes that see light the way human eyes do, Webb sees in infrared wavelengths. This allows it to peer through cosmic dust and gas to reveal the true composition of distant objects. The telescope's main mirror, composed of 18 hexagonal segments coated in a microscopically thin layer of gold, can collect light that has been traveling through space for billions of years. Its instruments are so sensitive they can detect the heat signature of a candle flame on the Moon. When this incredible machine was turned toward 3I Atlas, it revealed details that no one was prepared for. The first infrared images came back showing something completely unexpected. Instead of the diffuse, fuzzy glow typically seen around comets, Webb captured a tight, focused plume of superheated material streaming away from the object. This jet was so narrow and precisely directed that it looked almost artificial, like the exhaust from a spacecraft engine rather than the random outgassing expected from a natural comet. The plume maintained its focus across hundreds of thousands of miles, suggesting whatever was creating it was operating with remarkable precision and control. Webb's spectrometers went to work breaking down the light from this plume into its component wavelengths, creating a detailed chemical fingerprint of exactly what was being expelled into space. The results that came back would challenge everything astronomers thought they knew about interstellar objects. The chemical signature that broke physics. When the spectroscopic data from Webb was first analyzed, scientists thought there might be an error in the instruments. The chemical composition of the plume streaming from 3I Atlas was unlike anything ever detected from a natural comet or asteroid. Every icy body in our solar system follows the same basic recipe, being primarily composed of water ice mixed with dust, rocks, and small amounts of other frozen gases like carbon monoxide and methane. But 3I Atlas was pumping out a gas mixture that was 8 parts carbon dioxide to 1 part water. This ratio is completely backward from what nature produces in our cosmic neighborhood. Finding a comet made primarily of carbon dioxide is like discovering a fish that breathes air or a bird that lives underwater. It suggests formation conditions that do not exist anywhere in our solar system and raises questions about what kinds of environments might create such unusual objects. The strangeness did not stop there. Hidden within the carbon dioxide-dominated plume, Webb's sensitive instruments detected traces of atomic nickel vapor, a discovery that sent shockwaves through the metallurgy and astronomy communities. Nickel is a common element in the universe, typically found locked up in metallic cores of planets and asteroids, always accompanied by its cosmic twin, iron. These two metals are forged together in the nuclear furnaces of dying stars and remain inseparable throughout their journey across the galaxy. But the nickel streaming from 3I Atlas was completely pure, with no trace of iron anywhere in the spectrum. The only known processes that can separate nickel from iron are industrial ones developed here on Earth for manufacturing purposes. The most common method uses carbon monoxide gas at high temperatures to extract and purify nickel from mixed metal ores. Remarkably, Webb also detected carbon monoxide in the plume from 3I Atlas in exactly the proportions you would expect to see in a nickel refining operation. This discovery has led some researchers to suggest that what they are observing is not natural outgassing, but the exhaust from some form of manufacturing process. The idea that an interstellar object might contain active industrial equipment sounds like science fiction, but the chemical evidence is difficult to explain any other way. Adding to the mystery, the spectral analysis revealed trace amounts of xenon and krypton, noble gases that are commonly used as propellant in ion drive systems on human spacecraft. A path too perfect to be random. While the chemical composition of 3I Atlas is strange enough to keep researchers busy for years, the path it has taken through our solar system is equally baffling. Space is an incredibly vast and mostly empty place, with distances between star systems measured in trillions of miles. The chances of any random object from another stellar system finding its way to our small corner of the galaxy are already astronomically small. But 3I Atlas did not just stumble into our solar system by accident. Its trajectory is so precisely calculated and fuel-efficient that it appears to have been carefully planned. The object entered our solar system on a path that is tilted only 5 degrees from the ecliptic plane, the flat disk where Earth and the other major planets orbit the Sun. This alignment is statistically so unlikely that most computers would round the probability down to 0. As 3I Atlas made its way deeper into our solar system, it performed what can only be described as a grand tour of our planetary neighbors. Its path brought it into gravitational alignment with Jupiter first, allowing the massive planet's gravity to alter its course while providing a speed boost. From there, it swung past Mars, using that planet's gravitational field for another course correction, before making a close approach to Venus. Each of these encounters would have been perfectly timed to maximize the gravitational assist while minimizing fuel expenditure. This type of trajectory planning is exactly what human space agencies use when sending probes to explore the outer solar system. The Voyager missions, Cassini, and New Horizons all used similar gravitational slingshot maneuvers to reach their destinations while conserving fuel. The precision becomes even more remarkable when you consider the timing involved. For this gravitational tour to work, 3I Atlas would have had to begin its journey from its origin star system thousands of years ago, with its course calculated to arrive at our solar system at exactly the right moment when all the planets would be in the correct position. This level of long-term planning and navigation accuracy implies technological capabilities that far exceed anything humanity has achieved, the engine that shouldn't exist. The most perplexing aspect of 3I's Atlas is the mysterious force that continues to accelerate it as it travels through space. When astronomers first detected this non-gravitational acceleration, they measured it at approximately 4 × 10⁻⁷ meters per second squared. While this might sound like a tiny amount, it represents a constant force acting on an object that could weigh billions of tons. The direction of this acceleration is what makes it truly extraordinary. Throughout history, every comet observed by human astronomers has followed the same basic pattern when approaching the Sun. Solar heating causes surface ice to vaporize, creating jets of gas and dust that stream away from the comet's nucleus. This outgassing creates a natural rocket effect that pushes the comet away from the Sun, following Newton's third law that every action has an equal and opposite reaction. But 3I Atlas is accelerating toward the Sun, which would require its propulsive jets to be located on the side of the object facing away from our star. This cold, shadowed hemisphere receives almost no solar energy, making it impossible for natural sublimation processes to generate the observed thrust. The only way this configuration makes sense is if something inside 3I Atlas is actively generating propulsion, independent of solar heating or any other external energy source. The characteristics of this thrust are remarkably similar to what engineers would expect from an ion drive system. Ion propulsion works by using electrical energy to ionize atoms of propellant gas, then accelerating these charged particles to extremely high velocities using magnetic fields. The result is a very low-level but highly efficient form of thrust that can operate continuously for years. The exhaust from an ion drive appears as a narrow, focused beam of ionized particles that glows in the infrared spectrum due to the kinetic energy of the accelerated atoms. This matches exactly what Webb observed streaming from 3I Atlas, suggesting the object may be equipped with propulsion technology similar to our own, but operating on a much larger scale. The presence of xenon and krypton in the exhaust provides additional evidence for this theory, as these are the exact propellant gases used in human ion drive systems. If 3I Atlas is indeed powered by some form of ion propulsion, then its sunward acceleration could be explained as a prolonged braking maneuver. An object traveling at interstellar speeds would need to slow down significantly to be captured by our sun's gravitational field, a giant among space travelers. The sheer physical scale of 3I Atlas adds another layer of mystery to an already perplexing situation. Initial observations suggest the object measures approximately 28 miles in diameter, making it larger than many of the asteroids in our own solar system's main belt. To put this size in perspective, 3I Atlas is bigger than the asteroid that struck Earth 65 million years ago and ended the age of dinosaurs. Objects of this size should not be common in the space between star systems. The process by which planets and asteroids are ejected from their home systems typically involves gravitational encounters that favor smaller bodies. Massive objects like 3I Atlas would require extraordinary circumstances to be thrown out of their birth system with enough velocity to travel between stars. If such enormous interstellar wanderers were common, our sky surveys should have detected hundreds or thousands of smaller examples before encountering something this large. But we have not seen those smaller objects. Despite decades of systematic searches, 3I Atlas represents only the third confirmed interstellar visitor ever detected. The previous two objects, Oumuamua and 2I Borisov, were much smaller and behaved more like typical asteroids or comets. The fact that our third interstellar encounter involves something so dramatically different in size and behavior suggests we may be dealing with an entirely different class of object. The enormous size of 3I Atlas also raises questions about its internal structure and composition. A solid rock or ice ball 28 miles across would have a mass measured in hundreds of billions of tons, requiring tremendous energy to accelerate or decelerate. But if the object is hollow or partially hollow, as might be expected for an artificial structure, its mass could be significantly less while still maintaining its impressive external dimension. This possibility opens up speculation about what such a vast artificial structure might contain. A hollow space 28 miles in diameter could house entire cities, complete ecosystems, or industrial facilities on a scale that dwarfs anything humans have ever built. If 3I Atlas is indeed artificial, its size suggests capabilities and purposes that go far beyond simple exploration or scientific observation. Recent observations from both SOHO and SWAN solar monitoring satellites have detected several other unusual objects in our inner solar system, including one designated C2025 R2 SWAN that display similar anomalous acceleration patterns. This suggests that 3I Atlas may not be alone, and that we may be witnessing the arrival of multiple artificial objects from interstellar space. When natural laws stop working, the accumulation of evidence surrounding 3I Atlas has created an unprecedented situation in the scientific community. Each individual anomaly could potentially be explained through natural processes, but the combination of unusual chemistry, impossible trajectory, artificial acceleration, and enormous size creates a puzzle that challenges conventional explanations. Scientists are being forced to consider possibilities that were once confined to the realm of science fiction. The chemical signature alone presents multiple challenges to natural formation theories. Carbon dioxide-dominated comets are theoretically possible, but would require formation conditions that do not exist anywhere in our solar system. The temperatures and pressures needed to create such an object would have to exist in an environment completely different from anything we have observed. Even if such conditions existed somewhere in the galaxy, the statistical probability of such an object being ejected from its home system and arriving in ours remains vanishingly small. The presence of pure nickel vapor creates an even bigger problem for natural explanations. The industrial processes required to separate nickel from iron operate at temperatures and pressures that cannot be naturally sustained in the cold vacuum of space. The energy requirements alone would be enormous, requiring either an internal heat source or external energy input that has no known natural equivalent. The trajectory and propulsion characteristics of 3I Atlas compound these chemical mysteries. The mathematical precision of its path through our solar system would require navigation capabilities that can account for gravitational influences across multiple planets over extended time periods. The constant acceleration provides additional evidence of active control systems operating with remarkable consistency and efficiency. Traditional scientific methodology requires that extraordinary claims be supported by extraordinary evidence, but it also demands that researchers follow the evidence wherever it leads, even when the conclusions challenge established beliefs. The data from 3I Atlas is forcing astronomers to confront the possibility that not all objects in space are natural formations left over from the birth of star systems billions of years ago. The implications extend far beyond astronomy into fields like astrobiology, engineering, and philosophy. If 3I Atlas represents artificial technology, it would provide the first concrete evidence that intelligence capable of interstellar travel exists elsewhere in the galaxy. The technology that rewrites everything. If the artificial hypothesis for 3I Atlas proves correct, the technological implications are staggering. The object would represent engineering capabilities that exceed human achievement by orders of magnitude. The ability to construct, launch, and navigate a structure 28 miles across through interstellar space requires mastery of physics, materials science, and energy generation that we can barely imagine. The propulsion system alone would represent a breakthrough in space technology. Ion drives capable of accelerating such a massive object would require power generation systems on an industrial scale. The electrical energy needed to operate such engines continuously for the years or decades of an interstellar journey would exceed the total energy output of human civilization. The engineering required to build and maintain such systems while operating in the harsh environment of deep space represents technological mastery of the highest order. The navigation and guidance systems would be equally impressive, plotting a course from another star system to ours, accounting for the gravitational influences of multiple planets, and executing complex trajectory adjustments over thousands of years requires computational capabilities and long-term planning that surpass anything in human experience. The precision demonstrated by 3I Atlas suggests not just advanced technology, but also remarkable organizational capabilities and institutional stability. The materials science involved in constructing such an object presents additional challenges. Any structure intended for interstellar travel must withstand decades or centuries of exposure to cosmic radiation, micrometeorite impacts, and the extreme temperature variations of deep space. The fact that 3I Atlas appears to be operating normally after what must have been a journey measured in thousands of years speaks to materials and construction techniques far beyond current human capabilities. The industrial capacity required to build something like 3I Atlas would represent the output of an entire planetary economy. The raw materials alone would require mining operations on the scale of asteroid harvesting, while the manufacturing facilities would dwarf any industrial complex ever built on Earth. The coordination and resource allocation needed for such a project suggests a civilization with capabilities that extend far beyond anything humanity has achieved. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.